welcome to the next lesson in my series about C#. Today I will talk about loops, which are nothing more than instructions that repeat codes a specific number of times or until a certain condition is met. There are four types of loops, namely for each, while, and do while. The most basic type of loop is the while loop. Its purpose is to repeatedly run some codes we specify until a certain condition is met. In this slide, the while loop can be defined this way. In the example I wrote, the condition is any expression that produces a Boolean result, either true or false. This condition ultimately determines for how long the loop will continue to run. As long as the condition evaluates as true, the loop will continue to cycle through its codes. You can notice that the loop, like many other programming concepts, has a body delimited by curly brackets. It is between these curly brackets where we place the codes that we want to run repeatedly while the loop executes. For a more detailed analysis, these are the processes that occur in a while loop. First, the condition is evaluated. If it returns false, the loop will immediately end its execution and transfer it to the first code that follows after it. If the evaluation is true, then the codes in the loop's body are executed. When the last of this instruction finishes executing, the condition is evaluated again and the process repeats indefinitely, until the condition evaluates as false. If the condition never evaluates false, you will get what programmers call an infinite loop, a loop that will never end its execution, and it is considered rather an error than useful code. Some other property of loops is the fact that they are extremely high CPU power consumers. Loops cycle their instructions, process which is called iteration, extremely fast, and they basically demand so much attention from CPU that the rest of the program will become unresponsive while the iteration continues, and the CPU will simply ignore other inputs like mouse clicks or key presses. You probably have noticed programs that become unresponsive for a while when you click a button and perform some other action. It is highly likely that the culprit for such behavior is a loop, and we will learn at some point ways of avoiding hanging the whole application while loops run, but for now, just be aware that loops can and will demand a lot of processing power, and this is a normal and expected behavior. For a most simple example where a while loop can be used, this is how I can count from 0 to 9. The explanation is simple. I declared an int variable and initialized it with a value of 0. After that, I added a while loop, and as a condition, I am testing if my variable's value is less than 10. Whenever this condition is true, the loop will execute the codes inside it. Inside this body, I am simply displaying the value of my variable on the console, and also increment this value immediately after. If you don't know what incrementing is, just watch my video where I explain operators. The reason for incrementing its value is I need a way to end the loop somehow, and since the condition is for the value to be less than 10, all I need to do to end the loop is to continue to increment this value each iteration until it's no longer less than 10, in which case the execution will be transferred to the first instructions that follow after my loop. The next kind of loop is the do-while loop. It is basically identical to a while loop, with the only exception that the codes inside its body will always be executed at least once, even when the condition is evaluated as false. Its syntax is as following. So basically, a do-while loop is just a while loop with its order of functionality inversed. Instead of checking the condition and then executing the codes, we first execute the codes and then check if the condition is true, so that we execute them again. To illustrate this functionality, I will write a do-while loop that will help me calculate factorial numbers. For those of you that don't know or don't remember what factorial numbers are, the factorial of an integer positive number is a product of all the integers greater than 0 and less than or equal to the number itself. For instance, the factorial of 3 is 1 times 2 times 3, which equals 6. Programmatically, I can write the program to calculate factorial numbers automatically using a do-while loop like this. When the program runs, it first starts with a result of 1, then a consequent multiplication of the result of each iteration of the loop while reducing n by 1 until it reaches 0. This gives us a product that is described by this formula. This piece of code always runs at least once, that's why it will not work properly when n is less than or equal to 0. The next loop is the for loop. Its syntax is definitely more complex than the previous two loops, but it also offers greater control and solves more complicated tasks. Its syntax looks like this. Often, while the program repeats or cycles, or iterates instructions for a certain number of times, you will need to keep track of how many times these cycles ran. For this purpose, programmers use what's called a control variable. To easily understand the for loop, it can be broken down to 4 sections. The first section is the part where we declare or initialize our control variable. Notice that only numerical type variables can be declared here. The default initialization value is most of the time 0. The next section defines the condition that will end our loop. It is placed where we use the previously declared control variable in a conditional check, usually verifying if its value is greater or lesser than some value. The third section is the place where we increment or decrement our control variable in order to be able to meet the end condition at some point in time, thus avoiding an infinite loop. Finally, the last section is the body of the loop itself, where we place the codes to be cycled. It is a common programming convention to declare your control variable simply as I, which is the first letter of the word iterator. For a simple visualization of its behavior, I will rewrite our first while loop that counted from 0 to 10 using a for loop. The explanation is also simple. First, I declare a control variable named counter and I initialize it with the value 0. Next, I specify that I want my loop to run until this control variable's value is bigger than or equal to 10. Then I simply increment my control variable by 1 each time the loop cycles. Inside the body of my loop, I display the value of my control variable to the console. When I run my program, the compiler declared and initialized my control variable, then it checked if its value is smaller than 10, and when that condition returned true, it ran the codes inside the loop's body. When these codes finished executing, the compiler incremented the values of my control variable, then performed the check again, and so on until by incrementing it yet again. Its value got bigger than 9 and the condition evaluated as false, in which case the execution was immediately transferred after the loop's body. If instead of incrementing, I would have decremented my control variable and obviously instead of declaring it as 0, I would have declared it as 10 and specified the ending condition as the value being smaller than or equal to 0. My program would have counted down instead of up. Keep in mind that we are not constrained to increment or decrement by 1. We can use whatever value we need or want. We can even use mathematical operations, not necessarily incrementation or decrementation. There is one important thing that I need to explain to you, even though it relies on a concept I did not teach you: variable scope. This basically describes the region where a variable is visible and can be used. Take this example. This example concludes that whenever we declare a controlled variable inside our for loops, that variable can only be used inside the body of that loop and nowhere else. If we try to use the control variable after the body of our loop ends, we will get a compiler error stating that it does not know of any such variable. If we really need a control variable that we can recognize outside the body of our loop, though this is a very rare case, we can simply declare it outside the body of our loop, in which case we omit to declare it inside the loop itself. However, we still need to type the semicolon character of that section. In this example, the noun variable is visible both inside and outside the loop's body because we declare it outside of it. So, whenever the loop ends its execution, the control variable continues to exist. Declaration and initialization of our control variable is not the only thing that we can omit while we declare our for loops. In this example, I am declaring my control variable outside the loop's body and I'm incrementing its value inside of it. Ultimately, you can even declare for loops without any parameters with empty sections like this, though I don't know why in God's name anyone would want to do this, since the loop will continue to iterate until the end of times or until you close the program. As a bonus, you can also declare multiple control variables inside your for loops, and you can also specify multiple conditions for the loop's ending section. Now, the last type of loop is also the hardest to explain, even though its behavior is rather simple because it relies on concepts I haven't explained yet. As a very dry definition, I can tell you that the for each loop will iterate through all the elements of a collection of elements. Of course, I will explain collections such as arrays or lists when the time is right, but for now you can think of them as an ordered sequence of elements of the same kind, like integers, strings, etc. So instead of having multiple separate variables of a certain type, a collection is a variable that can pack multiple variables of that type inside of it. First, the form of a for each loop is this. Second, this is a practical example of how to use it. In my example, I have declared two specific types of collections known as arrays, one of type int and one of type string. They are simply variables that I initialize with multiple values at once. In the end, I use the for each loop to iterate through all these values one by one. When I talked about C# keywords, two of these keywords I listed back then were break and continue. These keywords are useful in context of loops. The break operator is used whenever we want to end the loop immediately, even before ending its execution in a natural way. Whenever the break operator is met, the execution of the loop is immediately stopped and the program continues executing the first instruction that follows after the loop. A loop termination using the break operator can only be performed from within the loop's body and only on a iteration of the loop. If you paid attention to my example, I declare a while loop for which instead of a condition I place directly the true keyword. That actually means that the condition will always be true and the loop will never end. However, inside the loop's body I'm performing another check, and whenever that condition is true, I'm using the break operator to break out of the loop, to end its execution and continue with whatever codes follow after my loop. The other keyword, the continue operator, is somehow similar to the break one in some aspects. The difference between them is the fact that whenever we use the continue operator, the remaining codes that follow after it inside the loop body will not get executed, but the loop will not end its execution. Instead, it will jump to the next iteration. In other words, we can use the continue operator whenever we want to skip a cycle. In my example above, I make use of the continue operator to skip displaying numbers that are even and only display odd ones. Whenever we divide an even number by 2, the remainder will always be 0 and 1 when we divide odd numbers by 2. This is all I need in order to skip cycles when this remainder is not 0. If you stayed with me up to this point, you may find out that just like the conditional constructs, we can also nest loops. This means declaring loops inside other loops. They are somewhat harder to grasp by beginners, but you can imagine them as the innermost loop being executed the most times, while the outermost the least times. This is because an inner loop has to run all its cycles for each cycle of the outer loop. This example proves this nesting concept. In the outer loop, I declare the variable x and I am incrementing this variable while its value is less than 2. In the inner loop, I declare the variable called y and specify the ending condition as y being less than 10. Now, when the program ran, whenever the outer loop iterated once, the inner loop ran all its cycles, meaning 10 times. Since the outer loop ran twice, the inner loop was ran 20 times. This is all about loops. You will come to understand that they are a strong and highly used concept of programming, and you will thank them for allowing you to perform iterations like this. And since I mentioned collections, in the next lesson I will talk about arrays. Until then, all the best to you guys. Bye!